Hello and welcome to yet another lecture on basic electrical engineering paper code ESEE101. Myself Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Institute of Technology and Sports Complex, Department of Electrical Engineering. Today, my topic is voltage source inverter. Lesson objective. After the end of this topic, students will be able to understand the concept of voltage source inverter. So today's topic, voltage source inverter or VSI. So DC input power is converted to AC output power in an inverter using power electronic circuit. So general conception of an inverter is to convert a DC input power to AC output power. The output voltage and frequency is controllable for a static inverter. However, for such power electronic inverter circuits, the output voltage waveform is not purely sinusoidal in nature, but can be made of periodic waveform that is closely same to that of a sinusoidal voltage. So the inverters may be of a single phase type or three phase type, and they are used in many industry applications, including heating, uninterrupted power supply, instrumentation, and in electrical machine control. So, voltage source inverter or VSI. A voltage source inverter is the most commonly used static inverter. In this circuit, the input DC voltage source is constant and independent to the load current at the output of the inverter. So in this circuit, the DC voltage source that is constant and it is independent to the load current VSI that is independent to the load current at the output of the inverter. The constant DC voltage source at the input side may be obtained either from a control rectifier or from a battery. Usually, a large capacitor is placed across the DC source at the input of the inverter so that switching operates within the inverter circuit doesn't alter the input DC voltage circuit, which in turn doesn't alter the input DC voltage magnitude. The input capacitor charges and discharges as necessary to provide a stable output. In case of the VSI, that is the voltage source inverter, The output waveform is in the form of a square wave in most of the cases. So we will start our discussion with half bridge VLSI. Half bridge VSI, that is half bridge voltage source inverter. So this is the general pictorial view of half volt, half bridge VSI voltage source inverter. So these type of inverters are generally used in low power applications. The inverters, this type of inverters are consist of two switch. That is switch 1, it is clearly seen here, and another switch is called switch 2, that is clearly seen here. And two constant source power supply, that is this one, first one, and this is the second one. There are two diodes, the two diodes, that is D1 and D2 are there. They are given for the free wheeling action, that is known to us. It is given that the switching devices are generally transistors, thyristors, MOSFET, GTO or IGBT would replace those switches, that is two switches that we have used. And the load that is used here, the load, we are assuming that the load is resistive in nature. So let us discuss about the operation of half bridge. We can say the half bridge voltage source inverter. So the switch 1 and the switch 2, that is two switches are turned on and off. That is both of the switches are turned on and turned off in an alternative manner. So let us concentrate on the output voltage and the current waveform. So within the time period 0 to T2, the switch 1 is on and the output voltage is V0, that is became V in. Now for the time period T2 to T, the time period T2 to T, T2 means the T by 2. There are two time periods. One is 0 to T2, that is called T1, and another is 0 to T by 2, that is T1, 0 to T by 2, that is T1, and from T by 2 to T, that is T2. For the first time period, that is for the T1, the switch 1 is on, and for the second time period, switch 2 is on. So when switch 1 is on, the output voltage is V in, and when switch 2 is on, the output voltage is minus V in. So this cycle will repeat. So the frequency of that rectangular waveform that we have obtained, it given by frequency equal to 1 by T, the total time period. So by controlling the time period T, the frequency of the inverter output that can be varied. So we cannot able to turn on the two switches, that is switch 1 and switch 2 simultaneously because it may lead to the short circuit of the inverter input supply. So it is clear from the another figure, that is this one. This one suggested the inductive part that is in the load. The load energy keeps the continuity of the current through the freewheeling action of the diode. And this is the waveform that we have obtained when the diode D1 is on. With the help of the freewheeling effect, the input current is given here. Same pattern will be followed, that is the I2, that means when the switch 2 is on, the pattern of the input current that is seen, and this means the diode D2 is on. Here the diode D1 is on, here the diode D2 is on. And this is the entire output current. It is clear that the entire output current, the nature of the input entire output current, that is the diode D1 is on, again switch is W1 is on, followed by diode D2 is on, and again the switch is W2 is on. This is the entire output current. The nature of the entire output current, voltage and current waveform for the half bridge rectifier, half bridge VSI, the voltage source inverter. So the average voltage that we are obtaining, that we are assuming that the switch 1 and switch 2 are closed for the intervals T dash, that is T dash equal to T1 and T2. So the average voltage, that is the V0 of average, that will get V in into T dash by T by 2. So that is 2V in T dash by T. T dash by T is known to us as a duty cycle. So it will be equal to 2V in D, where duty cycle D is known as T dash divided by T dash plus T of, that is T dash by T. So from our previous discussion, that we have known that the RMS value of the output voltage is given by root over 2D into Vn. So if I assume that the load that is resistive in nature, the output current waveform will be same as the voltage waveform that we have already seen. So the average value of the output current, that is I0 average, is equal to V0 average by R. So the average current in each switch will be I0 average by 2, because there are two switches. So average load power, that is P0 or PO, that is given by V0 RMS square by R, that is equal to 2D V in square by R. Just putting the values of V0 RMS in this particular equation, we will get the average load power of half bridge inverter. Now it is clear that in case of the half bridge inverter, rectangular waveform is generated having values of plus V in to minus V in. Now another part of our discussion is the full bridge inverter. So this is the full basic circuit of single phase full bridge voltage source inverter. So it is nothing but if I see this pictorial view, it is clear that it is a combination of two half bridge voltage source inverter. It is a combination of two half bridge voltage source inverters. There are four switches, that is switch 1, switch 2, switch 3 and switch 4 are used, whether switches may be of any kind of power electronic semiconductor switches like transistor, thyristor, GTO, MOSFET or IGBT. And here we are using the four diodes, that is D1, D2, D3, D4, the four diodes, and this is the are used for a single phase voltage source full bridge inverter. So the switches of that inverter is turned on and off in an alternatively in an diagonal pairs. That means switch 1 and switch 4 is on at the same time. Diagonal pair means switch 1 and switch 4 is on at the same time, and for the other time that switch 2 and switch 3 is on together. So means first case the switch 1 and switch 4 is on together. For the second case switch 2 and switch 3 is on together, and same sequence that is followed for the off intervals of the switches is clearly written. For the off interval of the switches, the same pattern is follows. So each set that is turned on for the time interval t by 2. So DC voltage source, that is V in, that is connected to the load. It is clear that the DC voltage source will be connected to the load in alternative manner, that is mean in opposite direction. The output frequency of the AC voltage that is generated, it can be controlled by the rate at which the switch open and close. The rate at which the switch open and close, with the help of this we can control the frequency of AC generated voltage or generated AC voltage. So the operation is like that. Once the diagonal pair means switch 1 or switch and switch 4 or switch 2 or switch 3, that is the diagonal pairs of the switches are turned on at equal intervals, that is the interval of t by 2, the output voltage waveform is a square waveform with a peak amplitude of V in. So it is clear from the output voltage waveform of the full bridge inverter, it is clear that it is varied from plus V in to minus V in, and the same interval, that is for the when the switch 1 and switch 4 is on for the interval 0 to t by 2, the output voltage is plus V in, and for the interval t by 2 to t, same interval, the output voltage is minus V in when the switch 2 and switch 3 is on. The same pattern will be followed. So when switch 1 and switch 4 is on for the same interval, keeping the interval same, the output voltage is V in, and when switch 2 and switch 3 is on, the output voltage is minus V in. So it is clear that the output waveform is identical for the half bridge and the full bridge inverter. So all the equations that we have done for the half bridge, that will remain same for the both the, but the amplitude of the output voltage and the output power for the full bridge are twice that of half bridge. So here is the switching sequence that we have seen. There are four states, that is state 1, state 2, state 3 and state 4. For state 1, switch 1 and switch 4 is on, switch 2 and switch 3 is off. The output voltage is plus V in. For state 2, switch 2 and 3 is on and switch 1 and 4 is off. So the output voltage is minus V in. For state 3, switch 1 and 4 is again on, switch 2 and switch 3 is off. The output voltage is plus V in. Now for the state 4, switch 1 and switch 4 is off, switch 2 and 3 is on. The output voltage is minus V in. So this is the switching sequence. So if the load of the full bridge inverter, that is inductive, means RL load, the output current waveform will not be same. That is not the rectangular waveform, that of output voltage. It will follow the exponential form. So if I go to the formation, that during the interval when the output voltage is positive, the output current will rise exponentially. During the next pure cycle, when the output voltage is negative, the output current will decay exponentially. In the RL single phase full bridge voltage source inverter, the function of the freewheeling diodes is to provide a return path for the load current when switches are off. The freewheeling diode will provide the return path for the load current when all the switches are off. The source current is positive when the switches contact, and current and power is delivered to the load by source. The source current is negative when the diode conducts. Current and power is absorbed by the source. So this is a full bridge voltage and current waveform for a full bridge inverter, where the time interval is varied from 0 to t by 2 and from t by 2 to t. The help of the sequence, that switching sequence that we have already seen. For the positive, for the time interval 0 to t by 2, the output voltage is plus V, and for the time interval t by 2 to t, the output voltage is minus V. So in this way, the output voltage is varied. So if I concentrate on the output current figure, that is this portion for the output current, it means It is the current for ID1 and ID4, that particular part. If I saw this input current, that is the D1 and D4 is active, I have already told that the freewheeling diodes are there to provide a return path for the load current when switches are off. So means if I see the current through the switch 1 and 4, it is 0. That is means the switch is act as an open circuit. Means the both 1 and 4 switches are off. So means there is a function of D1 and D4, that is the current through the diode 1 and diode 4. Two diodes are operating. It will provide the return path of the load current and corresponding current I1, I0, that is follow that particular path of input current. So that is now when the switch start operating, if I saw the current of switch 1 and switch 4, that is switch start operating, it will increasing exponentially, or it will follow the pattern of the switch, and also the input current will like that when the switch 1 and switch 4 is operating. Now come to that particular part. From here, this will be the two diodes that it is clear that two diodes are operating, that is diode 2 and diode 3. So it is follow that particular pattern. It is follow the particular pattern, and up to that instant, the current through the switches 2 and switches 3 will be 0. And now the switch 2 and switch 3, up to that instant, the current through the switch 2 and switch 3 is 0. Now switch 3 is 2 and 3 is start operating. So means the current through that switch will be increasing, and it is clearly in the load pattern. So here is the pattern of the current when the D2 and D3, that is the input current, and when switch 2 and switch 3 is operating. So this is the entire output current. First it is going on increasing, that is again it is decreasing exponentially, and the cycle that is followed for a voltage and current waveform of full bridge inverter. Now take an example in order to understand that what we have discussed till now. It is given that a single phase half bridge inverter has a resistive load of 5 ohm, while the DC output voltage is 100 volt. Obtain the RMS output voltage and average output voltage. The output power. The second question is the output power, and the third one is the average and peak value of current through each switch. Assume the duty cycle is 0.5. So let's go to the solution. It is given that the input voltage is 100 volt and resistance is 5 ohm. So the output voltage that is known to us, that is the RMS output voltage, that is V0 RMS, it is root over 2D into V in. So root over 2 into half, because duty cycle is given 0.5. So it is root over 2 into half into V in, that is 100 volt. Now the average voltage, output voltage, we have first calculate the average, first calculate the RMS output voltage. Now we will calculate the average output voltage, that is V0 of average, it is equal to 2 V in into V. It is 2 into 100 into 0.5, that is equal to 100 volt. Now the second question that is given, to find the output power. We all know the output power is E0, that is equal to E0 square RMS by R, that is 100 square by 5, that is equal to 2 kilowatt. The third question that is given, you have to find the average and peak value of the current through each switch. I peak, it is nothing but equal to V in by R, that is 100 by 5 equal to 20 ampere. Resistance R equal to resistive load of R equal to 5 ohm. So the average value is nothing but the multiplication of peak value into duty cycle, that is 20 into 0.5, that is the average value of the current is multiplication of peak value into duty cycle, that is 20 into 0.5, that is 10 ampere. So we have learned that how for a so we have seen that the conception of voltage source inverter, the half bridge and the full bridge voltage source inverter. So the basic difference between the amplitude of output voltage and the output power of full bridge voltage source inverter are twice that is of half bridge voltage source inverter. So only difference is the amplitude of the output voltage and the output power of full bridge voltage source inverter are twice than that of half bridge half bridge voltage source inverter. Thank you.